This is Hi for Chapter 1. In this chapter we're going to be going over Pythagoras' theorem, trigonometry, a combination of both, and angle of elevation and depression. Here in exercise 1.1 we're going to be covering the basics of Pythagoras. Now Pythagoras' theorem is used to work at the missing side in a given triangle. Now when can it be used? Pythagoras' theorem can only be used when you have a right angle triangle and two sides are given and you expect it to work at the third. So in this question here we have a right angle, and the side that is opposite the right angle is called the hypotenuse. So this side here is called the hypotenuse. Now the formula to work out a missing side in a right angle triangle: a squared plus b squared equals to c squared. Now c squared will always be the hypotenuse, and a and b can be either one of the smaller sides. 12 squared plus 16 squared is going to equal to c squared. 144 plus 256 is going to equal to c squared. So c squared is going to equal to 400. Now to work out the value of c, you're going to square root this, so you square root this side as well. C equals to 20. And the question says, give your answer to three significant figures. So we have to show the third significant figure by putting a decimal here and a 0. And the units is centimeters. Question 5. Find the length of AG in the 3D diagram below. Give your answer to three significant figures. Now the line here, A to G. Now when you go from one corner to another corner on the other side, this is the longest length you can make inside a cuboid. Now to find the length of the longest side inside a cuboid, which is a diagonal, you can use the formula length squared plus width squared plus height squared, and then square root the whole. So that's going to equal to 8 squared plus 12 squared plus 6 squared. So AG is going to equal to the square root of 244. AG is going to equal to 15.6 centimeters, correct to three significant figures. Exercise 1.2. Here we're going to be covering trigonometry using the formula SO, CA, TOA. SO, CA, TOA. Now here we need to identify the hypotenuse, the adjacent, and the opposite. So the hypotenuse is a side opposite the right angle, and opposite is a side, well, of course, opposite the angle that we're going to be using. And then finally, adjacent is the remaining side. So here, the hypotenuse would be this side, opposite would be this side, and adjacent would be this side here. SO, CA, TOA. Each of them is its own formula. And you have to determine which formula to use depending on what's given to you. So SO is going to be sine theta, and theta is a Greek letter that we use to represent the angle. So sine then angle is going to equal to the opposite over hypotenuse. CA is cos theta equals to adjacent over hypotenuse, and TOA is tan theta equals to opposite over adjacent. So question 1, you have O, that's given to me because we're working it out, and we have H. O and H is in the first formula here. So we're going to use sine theta, which is 40, equals to opposite over hypotenuse. Now we want to work out the value of x, so we take the 10 to the other side, it becomes multiply. So x is going to equal to sine 40 times 10. So x is going to equal to, you plug this into the calculator as it is, 6.43 centimeters, correct to the nearest 2 decimal places. Question 3. This is a right angle, so this side would be the hypotenuse. This side is opposite the angle we're using, opposite, so this is adjacent. So we have the hypotenuse and we have the opposite. So we're going to use SO. So sine theta equals to opposite over hypotenuse. So we're going to be working out the angle. So we're going to replace the theta with A. So sine A, you can put in brackets, is going to equal to opposite 4.5 over 12. Now we want to get A by itself, so we're taking the sine to the other side. Now the opposite of sine on the calculator is sine inverse. The opposite of cos on the calculator is cos inverse. And the opposite of tan is tan inverse. To get on the calculator, all you have to do is press shift, then sine, shift, then cos, shift, then tan. So A is going to equal to sine inverse, then in brackets you're going to write 4.5 over 12. We plug this into the calculator as it is, and we're going to get 22.02 degrees. Question 6 is asking us to show that the exact value of sine 45 is root 2 over 2. Now how can we get sine 45? Now 45 degrees can be found, well, question 6 is asking us to show that the exact value of sine 45 is root 2 over 2. Now remember, when you're dealing with SOHCAHTOA, you have to use a right angle triangle. Now, if I had a right angle triangle with the angle 45 degrees, remember one angle is 90, the right angle, and the other angle is 45. So the third angle will be 45 as well. So essentially what we've made is an isosceles triangle. So let's try drawing it. Here we have the right angle. This is 45 and this is 45. Now let's see, what can we label the sides as? So these two sides are exactly the same because it's an isosceles triangle. So we can label them both as 1. Now 1 is a simple number to work with, so 1 centimeters here, 1 centimeters here. Now sine 45 is sine theta over hypotenuse, equals to opposite over hypotenuse. So sine 45 is opposite over hypotenuse. Now this is the hypotenuse. If this is the angle we're using, this is my opposite. So we don't have the hypotenuse, but we know this is a right angle triangle and we have two sides. So we can use Pythagoras to work out the hypotenuse. So hypotenuse squared is going to equal to 1 squared plus 1 squared. Hypotenuse squared is going to equal to 2. Hypotenuse is going to equal to the root of 2. So this side here is root 2. Now we can plug in the values. So sine 45 is going to equal to opposite over hypotenuse. Now over here we have root 2 over 2. Now to get rid of the root at the bottom, we have to rationalize it. So we're going to multiply it by root 2 times the top by root 2. So sine 45 is going to equal to root 2 over 2. And we've shown it. Now question B. is asking us to show that the exact value of cos 30 is root 3 over 2. Now, if I did draw a right angle triangle, and one angle would be 30, the other angle would be 60, because remember, all angles in a triangle add up to 180, so 90 here, 30 here, this has to be 60. So how do I label the sides? Well, all the sides are going to be different, so I have no way of knowing what this is or what this is. So therefore I can't be working out what the hypotenuse is. So we can't take this approach straight away. So let's draw a different triangle. 30 degrees, we know if we cut 60 degrees in half, that's going to give us 30. So let's draw a triangle where you find 60 degrees. And that's going to be an equilateral triangle. So all the angles and all the sides are the same. Now, if I cut it in half, that's going to create a right angle here. So we have our right angle triangle now. Now all the sides have to be the same. So if I label one side as 1, then this would be 1, and that would be 0.5 and 0.5, but we don't want to deal with decimals. So let's label all the sides as 2. So we have 2 centimeters here, 2 centimeters here, and 2 centimeters here. So this becomes 1 centimeter. This angle here is 60. This angle's been bisected, so it's 30. So we have our 30 degrees now. Now cos 30. So cos, instead of 30 we write theta. So remember, so, ka, toa equals to adjacent over hypotenuse. Now if you're using the 30, the side opposite is the 1 centimeter. So this is going to be our opposite. This is our hypotenuse, and this is our adjacent. Now we have the hypotenuse, we have the opposite, but we don't have the adjacent. Now to work at the adjacent, we have to use Pythagoras' theorem. So adjacent, so this is a hypotenuse, so you're going to do hypotenuse squared minus the smaller side square. So adjacent squared is going to equal to 4 minus 1. That's going to be 3. I'll square root both sides. The adjacent is the root of 3. So we have this side, we have the angle, and we have the hypotenuse. So let's substitute the values back into cos theta equals to adjacent over hypotenuse. So cos 30 is going to equal to root 3 over hypotenuse. And we've shown that the exact value of cos 30 is root 3 over 2. Question 7. Find the exact value of x in the following questions. All sides are given in centimeters and angles in degrees. Now for question 7, we're not allowed to use a calculator because we're asked to find the exact value of x. Now since we're dealing with SOHCAHTOA, we have to memorize certain values. We have to know cos, sine, and tan of certain angles. 0 degrees, 30 degrees, 45, 60, and 90 degrees. So to answer question 7, we have to go back to where the examples are. And this is a table that we have to memorize. So you have to know that sine 0 equals to 0. And that sine 0 equals to a half. Sine 45 equals to root 2 over 2, and so on. All of this has to be memorized. Now here where you have tan 90, it says plus minus infinity. Now tan 90, if you were to use a word, you would have to write down undefined, because we can't find a value for tan 90. So using this table, we're going to be answering question 7. We're going to be working through question 7b. So this is our hypotenuse. This side is opposite the angle we're using. So this is our opposite. This is our adjacent. So we have O and H. So ka, tawa. So we're using sine. So sine theta equals to opposite over hypotenuse. Sine 30 is going to equal to opposite, which is x over 11. Now the exact value of sine 30 is a half. So we're going to have x equals to sine 30 times 11. So x is going to equal to a half multiplied by 11. Now half of 11 is 5.5 centimeters. Exercise 1.3. Here we're going to be working out unknown sides and angles in the triangle. So question 3, we can see two triangles joined up, and we're asked to work at the missing angle x. Now when I look at this triangle ABD, I can see that there's a missing angle and there's one side given. There's not enough information here for me to actually work out the value of x. But I can see BD is a common side. What if I work out the length of BD, use that, and use the 7 to work out the angle x? So let's see. Let's look at this triangle here. Let's start with this triangle first. We have an angle and we have a side. Now, from what we've learnt, we can do trigonometry. But is it a right angle triangle? It is. How do we know this? They haven't put a right angle here, but we can figure out if we look at the question. AB is parallel to DC. So this line here is parallel to this line here. So that means that this angle and this angle alternate. So this also would be a right angle. So we're going to use SOHCAHTOA to work at the length of BD. So this is a hypotenuse, this is an opposite, and this is an adjacent. So we need to work out O. We have A. So TOA. So tan 32 equals to O, which is BD, over A, which is 2. So to work out BD, we're going to take 2 to the other side. So the length of BD is going to equal to tan 32 times 2, which is going to equal to 1.249738704. Now when you're doing a question like this where we're going to get long decimal numbers, or maybe any other question where you're going to get a long number, don't round them. We have to use the exact same values, and only the final answer can be rounded. Before the final answer, everything has to be as it's written on the calculator. So now that we have the length of BD, we need to figure out what we need to do here. So we want to work at the missing angle here. We want to work at the value of x. So if this is the angle we're using, this is our opposite, this is our hypotenuse, and this is our adjacent. So we have our opposite and hypotenuse. So we're going to use sine theta, so in this case x, equals to opposite, which is 1.24, and so on, divided by the hypotenuse, which is 7. So we take sine to the other side, it becomes sine inverse. So x is going to equal to 1.24 divided by 7. So remember, you have to write the full value. And we're going to take the sine inverse of this fraction here. So x is going to equal to 10.3 degrees, correct to 1 decimal place. Question 3. Ahmed downloaded these plans to make a kite. Use trigonometry to calculate the length x and the angle y. Now here, when I look at this triangle here, I have this missing side x, this side 40, and this angle 25. So if I'm using this angle here, it's opposite this side. So this is my opposite. This is my right angle. So the side opposite the right angle is the hypotenuse. So this is adjacent. So we have O and A. So we're going to be using TOA. So tan theta equals to opposite over adjacent. So tan 25 is going to equal to x over 40. And to work out the value of x, you take 40 to the other side. So x is going to equal to tan 25 times 40. So when you multiply the two, x is going to equal to 18.65 centimeters. This is correct to 2 decimal places. Now to work at the angle y, now remember this is a right angle, so this has to be a right angle here as well. These are all right angles. So it's a right angle triangle. We have the missing angle, so this is our opposite. This is my right angle, so this is my hypotenuse. So this is my adjacent. So again we have O and A, TOA. So tan theta is going to equal to opposite over adjacent. Now do we have the value x? We do. We worked it out in the previous part here. So instead of writing x here, we can replace it with what we just worked out. So you can write the actual value that you get on the calculator. So 18.6 and so on. So we take tan to the other side. So y is going to equal to 18.6 over 80. So when we take tan to the other side, it becomes tan inverse. So we're going to have tan inverse, then all of this in the brackets. Y is going to equal to 13.12 to 2 decimal places. Question B. Use Pythagoras' theorem to calculate the perimeter of the kite. Now to calculate the perimeter, we need to know all the outside sides. So we need to know the length of CB and BA. Now these two sides are identical, so if I can work out one of them, I know the other. That's the same case over here. So if I work at the length of DC, I can find the length of DA. So to find the length of DC, I have the length of this side here, and I have the length of this side here. So I can use Pythagoras to work out the length of DC. So DC is going to equal to, so DC squared equals to 40 squared plus x squared. And x squared was 18.65230,633. So we're going to work that out. So DC squared equals to 40 squared plus 18.65230,633 squared. So you square root this side. So DC is going to equal to 44.13511676 centimeters. Now we need to find the length of BC. So let's go back up and see what we have. Now to find the length of BC, so we have the value of x and we have the length of this. So again, we can use Pythagoras to work out BC. So BC squared is going to equal to 80 squared plus 18.65230,633 squared. And to work out the length of BC, you square root this side. So you square root this side. So BC is going to equal to 82.14565,437. Now we know there's two sides with this length and two sides with this length. So the perimeter is going to equal to 2 times 44.13 and so on, plus 2 times 82.1, so on. So when you pop this in the calculator, the perimeter is going to equal to 252.5615,423. Round this to the nearest 2 decimal places, and that is going to give us 252.56 centimeters. Angle of elevation and depression. Now, angle of elevation is when you have an observer and an object above him or her, and you're looking straight at the object. You're going to get an angle of elevation. Now, angle of depression is when the observer is above the object. So if you look at this diagram here, you have the observer looking upwards at the object. So from the line of sight, from the start, we're going to draw a horizontal line, and the angle between the object and the observer and the horizontal line from here, this is going to be the angle of elevation. Now, if someone was in the hot air balloon and looking downwards at this person here, so you would have a horizontal line here, and this angle in between is going to be the angle of depression because they're looking downwards. What you need to remember that this line and this line are perfectly horizontal, so therefore they're parallel. So whatever angle you're going to have here is going to be the exact same as the angle here, because these two are going to be alternate. Exercise 1.5. Question 2. Claire and Bill are on opposite sides of a building of 150 meters high. The angle of elevation between them and the top of the building is 40 degrees and 55 degrees respectively. Find the distance between Claire and Bill. So we have a building, and the building is 150 meters tall. Now we have Claire over here, we have Bill over here. Now Claire is looking at the top of the building, and so is Bill. Now we want to find the distance between Claire and Bill. So we're going to draw a line from Claire to the building and Bill to the building. And the angles is 40 degrees and 55 degrees. So we're going to have 40 degrees here and 55 degrees here, because they've said it's the angle of elevation between them and the top of the building. So if they're over here, this is a horizontal line and this is the angle of elevation. So this has to be 40. Horizontal line, angle of elevation. This is the angle of elevation then. So what we need to do here is work at the length of this part here and the length of this part here and add the two up. So we can do that because we have the height of the building and we have the angle here. So we can work out the distance between Claire and the building. So this is my angle, so this is my opposite. This is my hypotenuse, as this is a right angle. So this is my adjacent. So I need to find the adjacent when I have the opposite. Same case scenario here. Hypotenuse and adjacent. So to work at the adjacent here, so let's write down tan 40 equals to 150 over, so let's write A over here, B over here, and X over here. So this line is going to be CX and this line is going to be BX. So CX. Now to work at the value of cx, we're going to take this to the other side, as we can't move the numerator. So tan 40 times cx equals to 150. So cx is going to equal to, you take tan 40 to the other side, it becomes divide 150 divided by tan 40. So cx is going to equal to 178.7630, and so on. Now we want to work at the length of bx. Bx is going to be the same, so we're going to have tan 55 equals to opposite over adjacent. So tan 55 times bx equals to 150. So bx is going to equal to 150 divided by tan 55. Bx is going to equal to 105.03, and so on. So we're going to do bx plus cx, and that's going to give me the length of CB, from C all the way to B. So you add up the two numbers, we're going to get 283.7941696. So we're going to round it to two decimal places, and that's going to give us 283.79, and this is in meters. So we're going to put m here. This is rounded to two decimal places. Question 5. Find the measure of the angle of elevation of the sun when a vertical post 15 feet tall casts a shadow 15 feet long. So we're going to have our post (15 feet), and here's a shadow 20 feet long. Now the angle of elevation of the sun, so we're going to be looking at the sun, and I don't recommend staring at the sun, not good for your eyes. So we want to work out this angle here, so we're going to put x here. So the angle of elevation is going to be, well, let's see, what do we have? We have a right angle, then we have a hypotenuse here. This is the angle we're using, so this is my opposite and my adjacent. So we're going to have tan x is going to equal to 15 over 20. So x is going to equal to tan inverse of 15 over 20. X is going to equal to 36.9 degrees. This is correct to one decimal place.